distance of that number from 0. So when we have negative 2, the absolute value of that is 2 because it's 2 units from 0. When we have a regular 2, the absolute value of that is also 2. So remembering how that works and noting that, if you look to the left now at the example we've written, if I said the absolute value of some number I don't know is 3, the idea is that it could actually be two things. In place of that x, I could have had a negative 3, because the absolute value of negative 3 still gives me a 3. Or I could have had a positive 3, because the absolute value of positive 3 is equal to 3. So looking at this basic example, we can get a pattern. We can say, okay, so x is equal to negative 3 or x is equal to positive 3. Let's extend this, though, by using the pattern that you might already be seeing. So let me make a slightly harder example. Let's say, for example, I said x minus 2, the absolute value of that, is equal to 5. So now I'm putting an equation inside this operation of absolute value. Basically, over here with that absolute value of x equals 3, basically I took the 3 and did what to it? Look at the answer. Yeah,
the opposite of it.
Yeah, I have the opposite of negative 3 and the regular 3, right? That's what we saw looking at the easy one. That whatever was inside the absolute value bars is equal to the negative of what we had and the positive, right? Because it's just a distance thing. So when I look at this equation here, I can treat it the same way. I can pull it down and say, okay, so if I drop the bars, what I'll have, x minus 2 is equal to negative 5, or x minus 2 is equal to positive 5. And that's kind of what I did here, guys. This right here was x equals negative 3 or x equals positive 3. When you drop those bars, what you will consistently do is you'll make it equal to the negative and to the positive of whatever was on the other side. And then you just have two equations to solve. You guys just now saw or statement. Let's see, solve along the left. What should we do? Okay, add 2 to both sides. Perfect. So x is equal to, we have a negative 3, because a negative 5 and a positive 2 gives me a negative 3. On the other equation, let's see, x minus 2 equals 5. Remember, the way you look at it is we want to get rid of the 2. It's a negative 2. The opposite of negative 2 is positive 2. And you do the same thing on both sides. Perfect. Yeah.
Miss Murphy?
Yes, ma'am.
Why wouldn't you take the opposite of the negative 2? Why would you take the opposite of the 5 when it's not in the bracket?
Okay, so somebody on the internet just said, hey, why am I not taking the opposite of what's on the inside? Why am I taking the opposite of what's on the outside? Look at the pattern, though, again, in the first problem. Whenever you had the absolute value of something you didn't know, the answer came out to be the negative of the stuff outside of the bracket, on the other side of the equals. You guys see that? So absolute value of something we don't know would either be a negative 3 or a positive 3. And the pattern will always be that. You don't play on the inside of the bars. When you drop the bars, you change whatever the regular stuff by itself was to negative and positive. You guys got that?
Okay, thanks. Yeah. Thank you.
You're welcome. Drop bars. And then look at positive or negative. And really looking at both, when I say or, what I'm saying is when you connect the two statements, you're using the word or in between. And then you solve it like always. And graphically, we know what that means. Or, was that a union or was that an intersection? A union,
A union.
Right? Okay. So on the picture, it means I get both answers. If x is either negative 3 or if x is 7, both of those things make me happy. Nothing else works, but both of those are okay. The negative 3 or the negative 7. Because let's test it. A negative 3 minus 2, if I tested it by plugging it back into x, negative 3 minus 2, what do I get? Oh, negative 5. Absolute value of negative 5, is that 5? Absolutely. Now try your 7. started minus 2. If you plug it in for the x, what do I get? Positive 5. Absolute value of positive 5? Okay, it's 5. Perfect. Chelsea. Well, see, actually, remember how when you're using the inequalities, for the dots, that means equal to? Well, that's here, even though I'm not coloring, I'm using the dot to say, hey, it's exactly equal to that. So that's why I plotted it that way. Good question. So yeah, it's closed dots because just like with your inequality signs, when you're allowing it to be equal to the number, you use a dot. Sometimes you could have used a bracket, but that wouldn't make sense here because you're not coloring. The dot makes a lot more sense. How are we doing so far, guys? Let's look at one more. And then before I change like the difficulty level.
So when you're using the brackets, you don't color in the line, you just put the dots.
When you just have plain equal to, you use a dot. Now when you're coloring, you can use a bracket or a dot, and that means the same thing, but if you're shading stuff, you still have to draw the line and the arrow. You guys got that too, right? In here? Okay. If we have absolute value of x plus 2 equals negative 8, or equals 8, excuse me. To drop these bars, what do I do?
Take the opposite of the 8.
Yeah, exactly. Make it positive and negative, or as I heard somebody else say, take the opposite of the 8. Or, you know, take the negative of the 8. So we have something like that. Not so bad, hopefully. You guys see the pattern, though? Really, all you do is you drop the bars, change it to the opposite, and then you're set to go. Not anything too bad, hopefully, for you. Let's solve for x. I want x by Kelly.
How do you know if you're going to put or and?
With this kind of thing, with the bars, you always put or. Okay. Now, in a second, I'm going to modify it, Kelly. But I'm talking about on the most basic ones with that equal sign, it's going to be or. When we have inequalities, it'll be a little different. I'm going to subtract 2 from both sides. So x is equal to, what is that? And then x is also equal to 6. Okay. So once again, either one of those work. I mean, you tell me all the answers, but either one works. And if you graph it, you just put a dot on negative 10, and you would put a dot on negative 6. Positive 6, excuse me. Yeah. Good. That's probably going to happen a lot. Because what it's doing is it's giving you the one that makes it negative on the inside, the one that when you plug it in gives you a negative 8, and it's giving you the one that gives it the positive 8. You see how that's happening every time? So a lot of times, yes, you'll get opposite signs. That's a good question. Let's make it a little bit harder and make sure you guys can deal with it. And of course, you can kind of see I'm working pretty close to the book. So I'm going to say 5 minus 3x in absolute value bars minus 8 equal to negative 4. I've made you guys have to do some prep work. Do you see it? Can you drop those bars like it is? Or is my stuff too mixed up still?
You can drop the bars.
Yeah, actually it's too mixed up. So even though you're tempted to drop the bars here, we can't just do that when we have a regular number there. That's going to mess with stuff. Our whole philosophy in the very beginning with that 3 was absolute value by itself on one side, number by itself on the other side. So to make that philosophy still carry on, to make it work, let's move that 8 over. Let's clean it up so that we only have an absolute value on one side, and then the numbers are on the other side. To move to negative 8, what do I do? Add. The opposite of a minus is a plus. Same thing both sides. So now I have 5 minus 3x in absolute value bars equals, what's a negative 4 into positive 8? You got it? Now I can drop the bars like I want to, right? Because I'll get 5 minus 3x. I always like the negative on the left. It doesn't actually matter. I just always write the negative to that thing up top on the left. And then you solve it, just like always. We want to get x by itself. So the first thing I'm going to go after is going to be my 5. 5 is attached how? Okay, it's a positive one, so it's basically by addition. So minus 5 on both sides. Negative 3x is equal to negative 9. Divide by negative 3, divide by negative 3. What are we getting x to be equal to? And actually, to be consistent with the author, I don't know if the word matters so much with the equals, but he's actually, I need to modify this, he's using the word and. He's saying both of these are answers. I'm sorry for that. With the equals, it doesn't make as much difference, but just notice that, okay, when you look in the back of the book, because he's saying that they're both working. Don't let it mess you up on the graphing. You are actually just keeping the 2 numbers. However you need to think about it, to know that you're not doing any weird intersection stuff, you're keeping both numbers, okay? Did that freak anybody out? It did freak somebody out? Okay. So it's the same thing. On the picture back here that we had, if you were graphing, I guess technically it would have been the or. I don't really know, but you're keeping both answers. Negative 3 and 7 are both working. So be a little bit free with which word you see with this kind in case he goes back and forth, okay? Just know that it is accepting both answers, however you like to think about it. Okay, over here on the right, I'm going to say minus 5 minus 5. Negative 3x equals, let's see, we have a 4 minus 5, that looks like a negative 1, right? Divide by negative 3. Okay. So we have those 2 answers. And actually, I'm not sure why he switched the words. To be honest with you, let me see. Maybe I just read it wrong. It looks like he does switch back and forth though when he's writing. As far as I'm concerned, if I see the 2 numbers and it's regular equal to stuff, I'm not going to be weird about and or. The only time really the and or become really important is when you're looking at the graph. Later, for the ones that have to shade stuff. For these, it's just both answers. Both of these work. That's the idea. Sorry for that inconsistency in the text. Okay. Let's talk about absolute value. So this is kind of where it gets a little fun. So now we're going to talk about absolute value as we have been, but now with the inequality stuff. So absolute value with inequalities. And there's 2 main ideas. I'm sorry it's so messy. That looks horrible. If you have a less than, what you're going to do is you sandwich it. You sandwich it between opposites and you solve like always. If your problem starts off with a greater than, and this includes less than, equal, and less than, and that includes greater than, equal, and greater than, okay, when I'm telling you these definitions. If you start off with those, you're going to give me an or. So you write it separately, because then it starts to matter. With these inequalities, that's when it actually does make a difference, okay? So write separately. With or. Other than these 2 principles, guys, everything else that you've learned about absolute value, about inequalities tonight will be the exact same. In other words, the main thing you learned tonight was, hey, if I multiply or divide by a negative, I better flip the sign. Okay, you'll keep that. The only thing will be in the very beginning. You have to drop your bars, and you have to decide which one to do. Whether you want to sandwich the thing or whether you want to do the or and make them separate. So